Okay, so in this section, our topic is security tests. So in the previous section, we talk about what is software security and what is the security analysis, static security analysis. And then we did a tutorial about static analysis to identify software vulnerabilities, right? So in this section, uh, so we will go through another type of software security assurance activity, security testing. Okay, static analysis is a static validation and verification. Testing, security testing is a dynamic verification and validation. Okay, so what is a security testing? So first, security testing is a process to ensure that mechanisms established to ensure security are not defective. Right? We run testing to ensure that there's no security bug. Okay, security testing. But if we don't find anything wrong, it doesn't mean the software is completely safe. Okay, this is the same like when we do functional testing. So when we don't find any bugs, it doesn't mean there is no bug. Okay, and the purpose of security testing is to verify that the system meets the security requirements. Okay, we test the system against the security requirements. So we talked about in the last section about security requirements, right? We know these sub-factors include confidentiality, integrity, authentication, and other things, right? Um, so what are steps to ensure the security of the system in terms of security testing, right? Let's look at, first of all, the security testing process, or we call it ST, follow the development process. As we discussed already in the first class and follow-up lectures. So software security, software quality assurance activities always happen in parallel with software development activities, right? So we have design, development, testing, maintenance. So this software development activity phases, and we also apply security testing or security analysis in each of these steps. Okay, and early testing is vital for security and the reliability of the software. Right, it's the same rule applied to all the quality factors. And the reviews and formal inspections are very important to identify security problems. And sometimes a rigorous security testing process is very important for building trust with customers. So customers need to know that we have run thorough security testing in order to trust our product. Okay. So here, there's two figures on the right. The first figure shows the proportion of test effort in the software development lifecycle. So here we see that during a design, right, and during development, the test effort the most, right? And during later on during deployment, maintenance, and definition, which is a requirement engineering. So the testing effort is the least. Okay. And the figure below shows a proportion of test effort according to test technique, right? So here when we talk about this testing, we mean security testing. Okay, we see process reviews and the manual inspections, reviews and inspections. They account for the most security test effort. Okay, followed by Okay, so that is a process reviews and manual inspections followed by code review, right? And smallest set is security testing. Okay. This is the effort. The reason behind it can be because security testing is usually, I mean, at least partially automated. So it doesn't require as much effort as reviews, inspections. That's a very resource, like time consuming, right? So this is the security testing process. Okay, uh, then let's before we talk about the details of a security testing, let's look at the life cycle of a vulnerability, right? This is a typical life cycle of a vulnerability. So first, the horizontal axis shows the time, right? Over time, what happens? The vertical axis shows the risk level, the higher, the bigger risk level. Okay. Uh, the security vulnerability is discovered. So someone discovered this security vulnerability. Either a hacker or someone examined the code to find the vulnerability here. For example, a few years ago, there was an Intel, there's a vulnerability in the Intel architecture, right? So they found this vulnerability, and that is the first stage. They found it. Okay. And then vulnerability is made public. So everyone knows there's a vulnerability. And some hackers also know they may try to exploit. The people using the system, they want to protect themselves against it. So it's public. Yeah, vulnerability, including vulnerability known to the vendor. The vendor notifies its client sometimes. For example, sometimes you receive an email from a credit card a company. They tell you there might be a vulnerability in our system. Your information might be exposed, right? Then, so people will update security tools to identify such security problems. So usually I also follow that is develop a patch to fix the security, right? And also to publish this patch to the public, to make public like recognizing the patch, and also install a patch on the systems impacted, right? So this is a basic life cycle of a vulnerability. If you want to look at more like examples, there are lots of examples online. You just search vulnerability database or vulnerability pool or real life vulnerabilities. There are lots of vulnerabilities. There's a famous website. You just search vulnerability list. So they tell you all the vulnerabilities and so when it appears and what's the impact of this vulnerability. Okay. So the first step of a security assurance is to elicit security requirements, right? There are different types of requirements. The first one is positive requirements. So these requirements describe the appropriate functionality of the system. It is like what the system should do, right? For example, the application must hide all private data that will be displayed, right? For example, we need to hide password information when you are inputting your password. That's a positive requirement. Negative requirement. This requirement describes what the application shouldn't do. For example, the application must not allow modification of the data without authority. It's a negative requirement. Abuse cases. Use cases about scenarios of unplanned or malicious use and this requirement describes how the application should react. So what if someone someone tries to get the password of others, right? So this is a malicious usage scenario. How should we react to those cases? Okay. And there's something called threat models we will discuss later that we can use to develop such negative requirements. Okay. The figure on the right, this figure shows, this is a use case diagram, right? So this figure shows an example about how we should protect the security and how others can exploit the security vulnerabilities. Okay, first the user logging into, you can consider is like a credit card website, right? First, a user enter username and password, right? So later there's a user authentication, right? And then the system, after since authenticated the user, it might be the two results. Authentication is successful or there's a failure. If it's successful, so it's fine. So in other cases, it might be denied, right? Maybe refused. Then maybe the user tries multiple times of the password, still failed, and then the system will lock the attempt, lock the account, right? And then the user might need to input a new password to set a new password for this account. Okay, so this is you can consider this is a usage scenario, and this scenario can be used to initiate our requirements. For example, one requirement can be, so after several times of failed authentication, the account will be unlocked. So that is a security requirements, right? But how the bad guys can leverage the process, right? How they can take advantage of the vulnerability of the system to get private information to attack the system. Okay, first of all, because we have a scenario people can input username and password, right? So the malicious system can actually use brute force to input username and password a large number of times, for example, 10,000 times or even more, or million times, to try different combination of usernames and password, right? So this will result two effects. The first effect is if they actually tried some combinations that are successful, right? So they can get the valid username and password. They can get a private information of the victims. Another scenario is fail, right? Most of them will fail. So they achieve another goal is to attack your system, which is called a dictionary attacks. They attack your system by trying different combinations and to make you to lock the account. This is called dictionary attack. Okay. So doing this, so this is a scenario where how we can protect our security and how other people can leverage the vulnerability of your system. Okay, and we should seek security requirements from this kind of usage cases or usage scenarios. So after we get these requirements, so we do security testing. Okay. So the same, the organization OWASP, right? So this organization posts the 10 top vulnerabilities, remember, in the last section. So this organization proposed a security testing framework, basically for each development phase, including design, requirement engineering, development, deployment, and maintenance and operations. So they define what kind of activities should be included for security assurance. First, before development, so we need to establish, for example, we need to establish quality standards and develop metrics and metric criteria to ensure security or traceability. During design, right, we should design a system to make sure it's secure. We need to revise our design architecture and compare different alternatives to make sure it's secure. Development, code review, inspections, static analysis to ensure security. After deployment, run penetration tests. So we'll talk about details of the penetration test later, and also we will do a tutorial to an exercise about the penetration tests. Okay. Deployment also, we have a configuration management testing. We add this security testing to our continuous integration, for example. And next is doing maintenance and operations. So during the maintenance of operations, we also need to ensure the security of the system, for example, by periodic control of the health of the system. Okay. So there are different security testing types. The first one is a vulnerability scanning, right? So what does it mean? So we want to find the vulnerabilities in the software according to known rules or templates. This is like the security analysis. So we have the vulnerability rules or templates, right? So we just to scan it according to these rules and templates. It's called vulnerability scanning. The second type is a penetration test. A penetration test is actually a simulation of a malicious attack and identify the degree of sensitivity of the vulnerabilities. So we know there's a vulnerability, then we simulate someone to attack the system according to the vulnerability. And in this way, we know how our system can react to the vulnerability, to react to the attack. Either the attack is successful, the system would expose private information, or the system would be damaged, or like attack is unsuccessful. So our system is powerful, and the security is guaranteed, right? And this is just too extreme. But there are some middle cases. For example, in some scenarios, you can expose some information, but in other cases, it's okay. This is a penetration testing. Basically, it's a simulation of attacks. Okay, and the other types include risk assessment. So after attack, we try to assess the impact of the attack. Right? Security audit. So perform reviews and inspections of the code and operating system. This is a security audit. And also ethical hacking. Ethical hacking is similar to penetration test, but it's actually a hacking. It's a systematic hacking by simulating multiple attacks, but with the intention of identifying vulnerabilities, actually simulating hackers to hack the system. It's not based on the known vulnerabilities, right? It's a simulating how hackers hack the system. But attention is not to get the private information or damage the system. Attention is to identify vulnerabilities. Okay. So these are types of security testing, and we will focus on penetration testing. Okay. And this is the most popular way to test the security of the system. What is penetration testing, or PT? So PT is a simulated and authorized attack to reveal possible exploits and their severity due to vulnerabilities. The two purposes: to reveal vulnerabilities. Also, the second purpose is to check the power of the system to defend itself. Okay. So penetration testing is usually part of security audits, right? So you want others to trust your system, you need to run penetration tests as part of the security audits. They can be performed internally by the software company themselves or by external authority or experts. Okay. So different phases of penetration testing. The first is recognition. So just to get important information about the target system, we need to know more about the system before we can actually attack the system, right? Scanning. This is to run some automatic scanning to know more about the vulnerability of the system. For example, we can find which ports are open or which input fields are vulnerable. For example, try different ports, we see which ports are open, then we do these open ports are it might be vulnerable for us to attack, right? Scanning. Get access. After we get these vulnerabilities, so we may exploit the identified vulnerabilities to attack the system or increase the level of authorization, right? Get access to a system. Then we maintain this access. Is activities to be able to stay in the system and get as much information as possible. Okay, this is to maintain the access. And also to cover attack, cover tracks, to cover traces, or like after we attack a system, we don't want to leave the evidence. So we want to remove the evidence, right? So for the attack to succeed, the attacker must erase all traces that the software has been compromised. Okay. Climbing is to go to further level. After a resource is compromised, for example, a password is stolen, attacker can continue to attack to the other resources with information obtained by the first step of the attack. For example, the first step of the attack is to get the account information of the administrator. We get username and password of the administrator. Then we can climbing to further leverage the information to get more information of the system, right? So these are the phases of penetration testing. Okay. Next, let's see. So what are the typical expected penetration test reports or penetration test results? Okay. So let's imagine there's a scenario, right? Scenario of attack. The initial discovery revealed a misconfigured DNS server that gave access to a list of hosts. A misconfigured DNS server gave access to a list of hosts, right? One of these hosts contained an interface of an administrative server protected by a password. Attacker was able to find the password with a brute force attack. First step, right? Is a full brute force attack to get access to the password. Then the administrative interface has been vulnerable to remote code injections, right? Attacker got access to the operating system. Then an attack on Java applet gave access to all machines used by administrators. Attacker managed to compromise the entire system. This is like, remember, it's a step-by-step attack, right? You get a piece of information and you use this piece of information to get more information, and you get until you get all the information. This is a scenario. So after running the penetration testing, what we can get, right? Basically, what we want to get is this similar to what we get from static analysis. We want to get vulnerabilities, a list of vulnerabilities, and also the priority, the severity of these vulnerabilities. For example, the first vulnerability is the username and password weak or default, right? This is we cannot find this in static analysis, right? So only when we do this penetration test and do dynamic test, we know this username and password are weak. Another vulnerability is a password reuse, for example. We need to fix this thing as well. And also share the local administrator password. Patch management, so multiple hosts have not been updated. Right, so these are the examples of the vulnerabilities that can be identified from a penetration test. Okay, it is different from what we get from static analysis, right? So one is dynamic, one is static. Okay, so we talk about penetration testing. We talk about static analysis. So why we have both of them, right? And what are the difference? For penetration test, it's after deployment. After we deploy the system on the web server, for example, we can do the penetration test. But secure static analysis is during the development, right? We use a static tool to scan the source code. Penetration tests must combine with manual effort. In most cases, you need to have a manual effort. For example, for the administrator case, right? For that scenario, first we need to get the account of the administrator. Then we leverage this information to do more, right? There's some manual information, manual effort involved. Static analysis is mostly automatic. So we just have done this tutorial. We know you just run it and it's do automatic scanning, right? So, automatic. Penetration tests increase the certainty of the risk. After you run a penetration test, if you find a vulnerability, most cases very likely it's an actual vulnerability because you are actually running the system. But for static analysis, you may not find so the false negative rate is very high. So static analysis is capable of early identification and minimization of a correction costs. Okay. So those are static analysis and penetration tests or security testing. So another way to ensure security of a system is a code security review, right? So remember, this is one of the largest part of security assurance activity, right? So the review, what is a process of auditing the code to verify that. First, security checks are in place. For example, we have so many top 10, we have top 10 vulnerabilities. And sometimes we know that people can change one field to another or change one username to another username. Right? We need to make sure in our code we have that check. We have the guarantee that that doesn't happen. Okay, so basically, the goal of the security review is to check whether security checks are in place. If you have very good code review, you don't need a penetration test. But normally, you cannot guarantee that your code review is complete, right? So the code review. So what's the preparation process? Remember, in our discussion of in our previous topic of review and inspections, there usually is a checklist, right? This is the same for security review. We have a checklist, right? And usually we use a threat model to define what we will check again, right? We define a security model based on checklist, okay? What is a security model? A security model is like the scenario where someone can attack the system, right? Like what information need to be included in a threat model? First one, threat agents. So what part of the users are vulnerable? So what part of user information are vulnerable, right? So where the service of attacks? So where is the application hosted? And the security checks, whether the security checks are enough, right? And what are the technical impact of the security issue? So what are the business impact of the security issue? We need to consider all this information. So this is a including a threat model. Okay. So when we do preparation, when we do preparation of security review, so we prepare such threat models. So best practice of security review include establish a threat model we just mentioned, and also combine automatic and manual efforts. Some rules can be checked automatically, right? For example, if you have a security checks that can be examined, some of them can be examined automatically, but many of them should be examined manually. Okay. So this is about how we as people to help this software system to ensure security, how to prevent others from attacking the system, right? Another way to ensure the security of the system is to let the system themselves to defend themselves, right? This is called a self-protective software. So the self-protective software would monitor whether there are malicious actions. If they identify such actions, they would take some measures to mitigate the impact of the actions. I'll give a very simple example. If the system detect someone is trying to get admin account of the system, right? But that people is not authorized to do this. So the system itself can maybe lock the account of that guy, or provide some action to protect the account of the admin, right? So the self-protective system. The software defends itself. Okay. How we do this, right? Actually, self-protection is implemented by inserting instructions into the application code to monitor and protect it. To insert instructions like logging, like tracing, or like other way to monitor what happens in our system. And when there's something wrong happen, we take the system itself would take some actions to mitigate the problems. Or we can use an external tool to monitor the system and to understand whether there are some problems and try to take mitigation actions. Okay. Advantages and disadvantages of self-protection. Self-protection has increased accuracy because actually monitor whether there's a problem is more accurate than you imagine whether there's a problem by scanning the code, right? So self-protective system not only detect vulnerabilities, but also try to block them, right? And the self-protective system can defend the application against various attacks and can defend the system against both internal and external threats. There are some disadvantages. Self-protective systems can affect the performance of the application that it protects, because we add extra instructions or use an external tool to monitor the system. When you monitor something, you're adding more resource consumption to our system, right? And the protective actions can warn an attacker. This is another disadvantage. The attacker will know that he's detected and he can modify his attack strategy. Last one is self-protective system is as good as the expertise and the experience of a security professionals. So if we have very experienced or experts in for this domain, we may not need self-adaptive systems. Okay. Okay. We talked about three things, right? Security tests, security review, and also self-protective systems. So next we will do a tutorial. So we will do exercise. In this exercise, we will run penetration tests. We will run this penetration test on the same subject system we did in our security, in our static analysis. Okay. All right, so let's